Hello and welcome. Today we're going to be talking a little bit about how to calculate gradient in different forms. Okay, so before you jump into this, you should have done a little bit in terms of gradient with straight lines in general. I'm just going to present it to you a couple of different ways, just so when we come across them, it's not unfamiliar. Okay, so just as a bit of a recap, we want to make sure that we understand what the gradient actually is. All right, it measures the slope of a line. Okay, basically how steep it is. Now, with the gradient, okay, we've all seen the formula, rise over run. We really want to understand what this means. This basically means the rise is our change in our y values, okay? And the run, because it's horizontal, okay, is our change in our x values. Now, when I say change, I want you to think of the word difference, okay? Meaning subtract. And we're going to come back to that very shortly when we sort of jump into it. Okay, so making sure that we understand everything that's going to happen. The first thing that we're going to look at is how do we calculate the gradient between 2 points. Now, there are faster ways of doing this, okay, but the visual method allows us to make sure that we're not going to make a mistake, okay, and we can go from there to understand basically what we're actually calculating, okay? All right, there will be faster ways in the future, but just for the moment, we're just going to understand through a picture. So between 2 points, we don't actually have the equation of the line. We don't have the image of the line. We're just given these 2 points. Calculate the gradient of the line that goes from to 1, 2, 4, 5. If you haven't got one, the first thing that you're going to do is you are going to draw a very quick picture, just so we know what's going on. Okay? So, how do we draw a very quick picture? It doesn't have to be a masterpiece or anything like that. Draw a very quick Cartesian plane, and eventually you'll get to the point where you don't even need a Cartesian plane with our x and our y. Okay? And then what we're going to do is we're going to plot both of these points. We're going to plot the first point. This one here, we'll do that in blue. That is 2, 1. So using our Cartesian plane, we're going to come roughly 2 across and then roughly 1 up. It doesn't have to be amazing. We're just trying to get a little bit of a sense of scale here. Okay, so we go across 2, up 1, and we place our point, 2, 1. I might just place that elsewhere. Okay, and you'll see why in just a moment. That's our point, 2, 1. Then, okay, we're going to graph the other line, the other point, sorry, which is the 0.45. Same thing, we're going to go 4 to the right and 5 up. So 4 to the right and 5 up to go and place this point. Okay, so 4 is going to be roughly double the length that we went on the horizontal. Okay, and 5 is going to be roughly 5 times higher. So it'll look something like that. Okay, there are 2 points. 2, 1, and 4, 5. And if I go and connect them with a little bit of a line, okay, what we're going to do now is we're going to form a triangle off of this, okay? All right, I'll form it with red here. If I go and form this triangle, this side here will be our rise, okay? That side here will be our run, okay? So, how do I go and calculate the rise and the run from the side of this triangle? Okay, well, if I'm going to go and calculate the rise, I'll just get my highlighter here. What I'm going to be looking for is my change in y. So remember back from when we started, we said m is equal to rise over our run, which is equal to our change in y over our change in x. And I said, when I said change, we'll be thinking of the difference. Well, have a little bit of a think here, right? If we're going to calculate the distance vertically, I have to go from this y value here of 1 all the way up to this y value here of 5. We can see already that the rise is going to be 4. But how do I calculate that if the points are really far apart? Well, it's equal to our higher value, our 5, minus our lower value for the y's. So 5 minus 1. When I go and calculate my my run, a similar thing is going to happen. So I'll highlight the run here just in a slightly different color. We'll do it in pink, going across there. Right, that's my horizontal distance. When I go and calculate my run, you can see that I'm going here from the value of 2 to the value of 4 on the x-axis. Okay, that means we're jumping across 2 squares. So we know our run is going to be 2 there. But if you have a little bit of a look, okay, and I take my higher value and I subtract my lower value in the x coordinate, okay, I also get the value of 2, okay, as you can see, right? So what we're thinking of when we're going to calculate our rise and our run, we're just subtracting the y values and we're subtracting the x values, okay? Now, putting this into our formula, our rise is 4, our run is 2. Simplifying that down, we have a lovely gradient of 2 just there to work with, okay? So the gradient of that line is just 2. All right, let's have a go at a little bit of another one. I'll scroll down, and then if you want to have a pause to attempt it first, okay, then by all means. Okay. Okay, so let's have a little go at this next one. Okay, again, we're calculating the gradient between 2 points. Okay, so when we go and do this, we want to really, really make sure that we're careful with any negatives that occur. And we want to make sure that we get the sign of the gradient correct, i.e. whether it's negative or positive. So if we don't have a picture, the first thing that we're going to do is we're going to add 1 in. Okay, now, first point is -1 and 8. So that means we're going to go across 1 and then up 8. Again, this doesn't have to be a picture perfect image, okay? Just try and give yourself a little bit of a sense of scale. So across 1 and up 8, I would have a point roughly sitting around there at -1 and 8, okay? Being very, very careful with how we set that out, okay? My next point, right, is then the point 3, 2. So I start here at the origin, I go across to the right 3, and then up 2. So across 3, and then up 2. Again, noticing here that I'm not making my picture absolutely perfect, okay? I'm just giving myself a little bit of an idea, okay? If I go and connect the line between those 2 points, okay, immediately what you're going to notice, okay, the line slopes to the left, which means we're going to expect a negative answer. Now, how do we go and do this? Again, same as the last question. I want you to construct your right angled triangle, okay? The bottom of that triangle here is going to be your run, okay? And the vertical of this triangle here will be your rise. So now let's put this all together. And I want us to be really, really, really careful here, okay? To help you out to understand and avoid some common mistakes that I see, okay? I'm going to label what's happening on this triangle very roughly. We go from the point 8 up here down to the point 2 here, okay? We could see if we were to go along the side of that triangle from 2 until 8, we would have a rise of 8 minus 2, which would equal 6, okay? Now, being very, very careful, and I'll do this in a purple color, just so we're not going to make any mistakes. So, going and putting everything together on this, okay? We're going to be going from -1 to 3. A really, really common mistake that I see occur, and I'll do this over the side in green, when we're going from -1 to 3, is I'll see students go 3 minus 1 for the run, okay, will give me 2. If we go and count all of the squares that go along the bottom of that triangle, though, from -1 to 3, we can actually see that there would be 4 squares to get there, ignoring the grid paper on my video, okay? Right, so be very, very, very careful with this, okay? From -1 to 3, we can see that there's a distance of 4 there, okay? Objectively. So what we want to do is we want to make sure that we can recreate that, okay? We can see what's happening. Again, remember, our run is equal to our change in our x. So when we go and calculate the magnitude with our higher minus our lower values, we can see that this 4 is going to pop out, okay? So 3 minus -1, okay, becomes 3 plus 1, which is equal to 4, which is what we were expecting. So be very, very careful when you're using negatives in this, okay? Right? Make sure that you actually look at your diagram, okay, and not just the numbers that are happening initially, because we don't want this mistake to happen up here to the top right, okay? Calculating. Our m is going to be equal to our rise over our run, okay? So our rise is 6, our run is 4, and we must remember that our line is sloping to the left, okay? So it has to be a negative, okay? Then we just simplify our fraction down, okay? Which will become minus 3 over 2. All right. Now, how do I make sure that I can do that all the time, even if I don't have a picture? Okay, right? Well, the picture helps and you can see what's happening. What I would like you to understand is what I've done in this particular example here. Okay, I've done higher minus my lower. I've done 8 minus 2. Okay, really, really useful for me to go and do that. So 8 minus 2. Okay, we know that's equal to 6. If I then go and apply the same order, where I do the minus 1 minus the 3, okay, on that particular point. So what I'm doing, just so we understand, is I'm taking the y value here, subtract the y value here. If I take the y value here, subtract the y value here. Here's what we end up with, okay? That would be minus 1 minus our 3. Let's go and do some simplification, okay? 8 minus 2 on top will be 6. Minus 1 minus 3 is negative 4, okay? Notice here, this does the automatic simplification of the negative for us without us having to remember, okay? Simplify it down, that becomes 3 on 2, and it doesn't matter where we place the negative, okay? If you're wanting to make it a little bit faster, that's an option for you as well. Don't feel like you have to, okay? You might prefer just to go and use this method of side lengths of the triangle, okay? All right. Thank you very much. In our next video, we're going to look at how we go and calculate the gradient through a table of values.